we want to look at what we call moment of inertia, right? Moment of inertia. How does moment of inertia works? It is very simple. Now, moment of inertia. Given this question, you want to calculate the moment of inertia of this question. Know that you can get moment of inertia for the x-axis, and you can get moment of inertia for the y-axis by formula. For the x-axis, this is your formula. Moment of inertia Ixx is equals to b d cube over 12 plus a dot a square. This is for the x-axis. For Iyy, it is the same, but in this case, you have, for this first one, the depth is taking what? Cube. For this second one, the breadth is taking cube. But the one we want to solve here is this first one. We want to solve the moment of inertia for the xxx. Now, what it means is that this question given to you, you separate it by saying component 1, component 2, component 3. Meaning this component 1, you get Ixx. Component 2, you get Ixx. Component 3, you get what? Ixx. Meaning that the total Ixx is what? Ixx1 plus Ixx2 plus Ixx3. You get the message? Now the question is, how do we get Ixx1 using this formula? How do we get Ixx2 using this formula? How do we get Ixx3 using this same formula? So we've tabulated our table. From here, what we need is what? BD cube over 12. Meaning I'm going to solve BD cube over 12 for component 1, BD cube over 12 for component 2, BD cube over 12 for component 3, right? Now, I will solve the area of component 1, the area of component 2, and the area of component 3, since that's what I need here. Then after that, I will solve for a square. Then having solved for a square, you input this value. Then you get your answer for component 1, component 2, and component 3. Now, let's see how it works. From here, your component 1, identify. From this diagram, this is your component 1. What's the area of this component 1? The length times breadth. Meaning, you have 100 times what? 20. And your answer is what? 2000. Now, what this y means is the centroid of this component 1. Now, how do you get centroid? The idea is simple. Now, first thing first, take a reference line for your x-axis. Take a reference line for your y and x-axis. Let's say you are taking this reference line. Let's say this is x and this is y. Now, we want to solve for the centroid of this first component at the y-axis. Now, check this component 1. What is the depth of this component 1? 20. The centroid is what? 10. The idea of centroid is that the whole weight of the body is acting at the midpoint. If from here to here is 20, the centroid becomes what? 10. Meaning 20 divided by 2, 10. Now, that 10, this is where you are going to. You are going to this x-axis. The remaining distance to get to this x-axis is what? Observe, 120. Meaning 10 plus 100 plus 20. That's what? 130. So for this component 1, your y is what? 130. And how do you get 130? 20 divided by 2 plus 100 plus 20. And that's how you got 130. Now, what is, moving on to the next column, AY. Your A is what? 2000. Your Y is what? 130. What's the value of this? 26. 26. 1, 2, 3, 4. You are done with this guy. Now, let's compute this value. BD cube over 12. Or before then, we will solve this later. We will solve all this later because what we actually need is where we want to solve for moment of inertia. What we are doing now, let's get the centroid first. Let's solve for the centroid. After solving the centroid, we solve for moment of inertia, meaning we compute these other values. Now, solving for the next one, component 2. What's your area of component 2? Identify your component 2 here. What's the length? What's the breadth? Meaning, from this component 2, from here to here is 20. the width is 20, then the height is what? 100. Meaning 100 times what? 100 times 20, and this is what? 2000. Now get the centroid as well using same idea. Now, like, you are going to the x-axis. What is the height of this component 2? 100. The centroid becomes what? 100 divided by 2. But you are going to this x-axis. What is the remaining distance to get here? 20. Meaning 100 divided by 2 plus 20. You then have what? 70. Is that clear? Now multiply. This time this is what? Alright, for the last one, the third component. What do you have for the third component? Same idea. What's the area? 60 times 20, and this is what? Now there is centroid. 20 divided by 2. So 20 over 2. This is what? 10. Now multiply. This time this is what? And that's it. Any questions so far? We've computed the value of the area of the centroid and the product of area and the centroid. Now, by definition, or by formula rather, what is centroid? What is the formula for centroid? What is the formula for centroid? Centroid, y bar is equals to summation of ay over summation of a. Now, let's get the summation of ay. What do you have? And let's get the summation of area here. What's our answer? 260,000 plus 140,000 plus 12,000. What's our answer? This is 260 plus 140. That's 400. 400 plus 12. That's 412,000. This is summation of ay. Now, summation of A is what? 2,000 plus 2,000, that's what? 4,000. 4,000 plus 1, 2, that's what? 5,200. Now, input this in your formula. Meaning, the centroid is what? 412,000 divided by 5200. This cancel out. So, what's the answer? What do you have? Okay, 79.2. So, y bar is what? 79.2 mm. We've solved our centroid for the y-axis, right? But the question says that calculate the moment of inertia, and this is the formula I want to use for moment of inertia. We are using BD cube over 12 plus A here is area, h squared. We will see the definition of h later. Now, the next step, after calculating your centroid, the next step, take this guy here. This is y-axis, this is x-axis, right? Now, say this is your origin. I get what I'm saying? Say this is your origin. What's the total length of this y-axis? 20 plus 100 plus 20. That's what? 140. 79.2. What will it be? Say you want to denote 79.2 across this y-axis. That's what? You are moving from 0 gradually. You get my point? It will be the second component. It will pass the average. Average is what? 70. But you're going to pass the average. Why? Because you got 79.2 mm. So let's say we are indicating this guy here. This is your centroid. Let's say you are indicating like this. Call it XX. Section. Yeah, let me use that word. Section it. In advanced class, we say there's something we call section. The idea of section is that you are separating. You are separating. Exactly. But don't use that idea. I'm just saying section. Don't say you are sectioning here. Just use this line. What this line means is sectioning. But just use this line to explain it. So you are saying you have XX. This is what we call neutral axis. Now, this guy, this H, it should be, you see that gradually now, it will get a little bit technical, but it is simple. It's logic. This guy, this H, we want to get this H. But this H is very confusing. It's confusing. But you see how it works now. Now, we've said that we've calculated our centroid to be what? 79.2 mm. You now come out to this diagram. Where will 79.2 mm be? If the total length is 140, you are saying that 79.2 should be somewhere here. Abi? 79.2 mm should be somewhere here. What this means is called neutral axis. To get the age of each component, for component 1, what the centroid you've calculated? 130. So 130, the difference between the centroid and this neutral axis will give you the age of component 1. Are you getting me? The difference between the centroid and this neutral axis will give you the value of age of component 1. You already know that the centroid of this guy is what? 130. Now let's take the 130 from the base as well. Meaning 130 will be above 79.22. So let's say you have 130 here. We'll call this 130. So 130 minus this guy will give you the value of H1. And that's what? So 130 minus 79.2. What do you have? 50.8 mm. So same idea. What's the centroid of component 2? The centroid is what? 70. You know, 70 will be below 79.2. Meaning 79.2 minus 70. And that's what? 79.2 minus 70. What's the answer? 9.2 mm. So then S3 will be what? S3 will be what? 79.2 minus 10. So you have 79.2 minus 10. And this is what? 69.2. So you are correct. Meaning Y bar, which is the total centroid of this shape, minus the centroid of each component. A square here becomes what? Then your A square is what? Hope you've taken those values down. Yes. 2580.64. The second h of component 2 is what? 84.64. The square. What do you have? 84.64. H of component 3 is what? 4788.64. Now we've gotten the H square of each component, component 1, component 2, and component 3. Now let's solve for the BD cube over 12 of each component. Now for component 1, what's the breadth? What's the depth? The depth here is 20. So you have 100 all into bracket 20 cube divided by 12. What's the answer? 666. Please confirm. 5, 6, 1, 2, 3, 4, 5.67. That's for the first component. Second component, BD cube over 12. What's your breadth? What's your depth? Your breadth is 20, your depth is 100. Meaning 20 all into bracket 100 cube over 12. What do you have? 1.66. 1, 2, 3, 4, 5, 6.67. Same idea for component 3. That becomes what? Your breadth depth. That's what? 60 all into bracket 20 cube divided by 12. What's the answer? 14,000. 40,000. Now, if you compare the value of this column and the value of this column, what's the moment of initial formula? BD cube over 12 plus AH squared. Now, you need to solve this guy of each component. Meaning, the AH squared of component 1, AH squared of component 2, AH squared of component 3. You know what I'm saying? When you are drawing your own table, include it. Include AH square of component 1, AH square of component 2, AH square of component 3. Now, why not? Of course, this is easier. Tabulating it is very easy. Here, from tabulation, you are seeing this, you you are seeing this, you are seeing this, you are seeing this. You get your full mark. You are still convinced about it. How we get H?
That's
H3.
yes.
Okay, this H3. Yeah, here is very simple now. From here, looking at this guy here, what was the total centroid we got is what?
130.
No, the centroid of this full shape is what? 79.2. So H1 is equals to, let's say the centroid of this one, let's say Y1, the centroid of this one, Y2, the centroid of this one, Y3. So to get H of this one, what it means is that H1 is equals to Y1 minus Y bar. H2 is equals to what? Y2 minus Y bar. H of the third component, Y3 minus Y bar. So now let's solve. Y1 minus Y bar is what? What the centroid of component 1, which is Y bar? 130 minus the total centroid you got is what? 79.2. And what's the answer? 54 point what? 50.8. 50.8 by the time you square it, that's how you got this. Same thing. H2 Y2 minus Y1. What's your Y2? Check here. Oh yeah, 70 minus your Y bar is what? 79.2. What's the difference? Negative 9.2. By the time you square it, negative 9.2 times negative 9.2. This is what you get. Now, for H of component 3, same idea. What's the centroid of component 3? 10. Meaning 10 minus the centroid of the O shape, which is what? 79.2. What's the answer to this? Negative 69.2. By the time you square it, you get this. So that's how you evaluate this H of each component. So now, from here, we wanted to solve this guy, right? BDQ over 12 plus AH squared. But let's solve AH squared of each component. Let's compute the value of AH squared of component 1, AH squared of component 2, and AH squared of component 3. For component 1, just that by AH squared, we are saying that the area here times this guy. So what's the answer? 5.161. 5.161. Is that times 10 raised to power 6. M raised to power 4. Then AH square of component 2. What's the answer? Meaning the area here, 2000 times 84.64. What's the answer? What's the answer? 1.693 times 10 raised to power 5 millimeter raised to power 4. Now, for the last one, AH square of component 3. That's what? Come back to your dad from your table here. A is what? 120. This is the summation. A is 120. Your A square is 4788.64. So multiply. What do you have? 5.746 times 10 raised to power 6 raised to power 4. Now we've gotten AH square of component 1, component 2, component 3. So we can compute the value of this column. Meaning this guy, the addition of this plus this. So what do you have? And what you are doing here is called what? The moment of inertia of what? Each component. So this is IXX. This is IXX. I'm going. This is IXX equals to BD cubed plus AH squared. So let's get the ISX1, IXX1, IXX2, and IXX3. For IXX1, what's our answer? 5.228 times 10 raised to power 6.
Yes.
6. IXX2, what's our answer? IXX2, meaning BD cube, which is this guy, plus what we got here. Please press your calculator very well, because this thing is not going to get another answer. Yeah, you're asking something before.
The IYY is your 1.8.
Yeah, IXX. Just that for moment of inertia, if the centroid is y bar, the moment of inertia is represented as IXX. If your centroid is x bar, the moment of inertia is represented as IYY. Get. So for ISX2, what's your answer? 1.836 times 10 raised to power 6. For the last one, what's the answer? Meaning this guy plus this, and that's what? 5.786 times 10 raised to power 6. Because initially we said to get our moment of inertia, IXX is equals to what? IXX1 plus IXX2 plus IXX3. Now solve this guy, the summation. That's our answer. Summation of IXX. What do you get? When you sum this up, what's the answer? 1.285 times 10 raised to power 7. What's the unit? What will be the unit? mm raised to power 4. So this is your final answer. Instead of 7, let's say 1.285 times 10 raised to power 4 times 10 raised to power 3 millimeter raised to power 4. So input this in your calculator. What will your answer be? 12,850 times 10 raised to power 3 millimeter raised to power 4. This is your moment of inertia along the x-axis for this figure. Now, the same way you solve for moment of inertia along the x-axis, you solve for the moment of inertia along the y-axis. Again, some person might say that solve the moment of inertia for the vertical axis and for the horizontal axis. What you just did here, this is for the vertical axis. You now solve for the horizontal axis. When solving for the horizontal axis, this formula, what it is? BD cube over 12. It will now be D cube B over 12. Meaning you will take your breadth as your depth.
Yes.
Take your depth as your breadth. This is just like you answering the first phase of this question. Phase 2, you now do the horizontal axis. But now, what I want you to know is that when we solve for this guy here, we are referencing to the x-axis, right? We took all the centroid, we reference it to the x-axis.
Yeah.
But for the y-axis now, we reference it to the what? Y-axis. You get? Meaning, let's say the centroid of this component 1, it will be what?
Everything is
50. This second one is what? 50. This one is what? Still 50. I mean the centroid of this guy. Just, any representation, you are still saying the same thing. It's just the way you understand it. So now let me ask you this question. With this tabulation, this tabulated form, and you solving like this, which one do you like?
This
This one is simple. Because you right, it's not like this one. Because it's very easy.
Where would I place the table?
Of course, you'll be giving paper now. You'll be right. Come here. Seeing this guy, you'll be seeing this one. You'll be seeing this one. You'll be seeing everything. No confusion. Sure, definitely. Inside the exam. They'll give you paper to no, you can't give paper inside. Even though your paper is not enough, request for more paper, they'll give you. So it's always advisable, tabulate your work so as to get a clearer solution for easier calculation. You get your answer. All right.